Why can't we just plug in our devices into a solar panel? Today I'm showing you the exciting world of direct coupling, giving every electrical appliance its own dedicated PV panel. No big battery bank required. This is the central scheme of the video. You will see it a few times. It represents the new term PV2COM or PV2 commodities that I made for this video. It is similar to P2X, power to something, but more specific. It moves the conversation away from how much battery do I need to what can I produce today. It's also similar to PV2 load, where I started, but I want to add the idea of storage in any of its forms. In this picture on the right side you see only 3 examples, but there are more. Heat, purified water, dried fruit, compressed air, etc. This approach brings real independence. It saves money and it gives you also peace of mind during heat waves or blackouts. And one panel can even produce hydrogen if you are careful. So let's get this hydrogen party started. Stick around, this is going to be real fun. Hello, I'm Norbert, energy engineer. In video 137 I'm introducing a fresh way to make work your PV panels harder and smarter. If you watch video 133, 134 and 135 especially, then you know already my B-team panels idea. Today we take it further. Here's why direct PV to load coupling is so powerful. Many physical processes have already some storage included, so heating water, producing ice or just producing cold, that has a kind of energy storage inherent in it. And in this way you need less batteries for the whole house. Just add a few well-matched solar panels here and there and leverage alternative and less expensive storage materials and approaches. Hydrogen production runs on DC, direct current. Store energy as a gas instead of expensive lithium. Here's an example with a perfect seasonal match. PV peaks in the summer, right on the moment that you need it for cooling. So store this cold directly in ice, in an ice box or in a fridge. And then you have extreme portability and resilience. We have less wiring and less centralized dependencies. Imagine thousands of small energy islands keeping critical devices running even during a blackout. And then finally, it's a great use for those B-team panels in video 135. Give them alternative work during peak sun hours instead of letting them idle. These small independent systems are simple, they are fun to build, and they are also based on alternative energy storage. Now the honest part. Every device needs its own coupling rules with a PV panel. Resistive loads like heaters or water boilers, but also LED lights, they are the easiest. Inductive or electronic loads, for example the compressors in fridges or the water pumps, they have big startup surges. And electrochemical processes like hydrogen production, they need careful voltage and current matching because of changing sunlight. And that's why a one-size-fits-all approach fails. But don't worry, I will break it down clearly in this new video series. And there will be a playlist for this DC to load coupling. Your PV panel's best operating point changes with the sun intensity, with the temperature and also with the load. Just like the engine RPM and the torque in your car, if it's not an EV. Connecting directly the PV panel to the load is like driving always in a second gear in your car. I once drove my Audi 100 Electro, and that was a prototype, in a second gear to 75 kilometers an hour. and with a gas engine it would have been a mess. An MPPT controller, that means maximum power point tracking, is very similar to a car gear, and you can even do it with a simple buck converter. It keeps the panel at its maximum power point, squeezing out 15 to 35% more from it, and that depends on the conditions. This will become a full video series with real building and tests. I have already ordered a DC fridge with a compressor, a premium brand MPPT, an 8 ampere hour small lithium buffer, supercapacitors and a 100 watt panel. And I will show you very soon exactly how to make an independent fridge that runs in the summer heat. And the battery or the supercap is only there as a buffer, not as a real storage, because otherwise the fridge will not be stable. And I am very curious to see which of the one is better, the supercapacitor or the small lithium battery. I will also build a practical DIY hydrogen production unit with one panel. In this video here you see already a video that I made about hydrogen 1 or 2 years ago. And I will also indicate the strong safety rules. And then we will look also at the production of drinking water. And the nice thing is, water can also be stored. And that represents energy that you have used for purification, but also to bring it from a deep well to a reservoir at 10-meter height. Now it's your turn. Tell me in the comments, which application do you like first? Refrigerator, water heating or hydrogen, or maybe something else? If you like this new direction of single panel independent solar solutions, hit the like button, share it with friends who care about resilience, and subscribe so you don't miss the playlist. Thanks for watching, and let's start building solar in a smarter way. I wish you good energy. And this is the solar energy, the solar PV panel, and then the plus and the minus go through this electrolyzer. And you see it here from nearby. And then here the electricity is led to the water. The water comes from the underside of this column. So that's distilled water, and that goes from this column here in the electrolyzer, and then here comes in this case the O2, so that's the oxygen that comes here. From here it goes from the electrolyzer, it goes into this column. Then you see here the bubbles coming, and then it will fill up this. So this water column will go down, and then you can measure here on the scale how much oxygen you produced. And the same is of course true also for the hydrogen. 2 atoms of hydrogen in 1 molecule of water. So this column will go down twice as quick as this column.